Hydrodynamics. So this is the study that deals with the motion of fluid and of the interaction of the fluid with its boundaries. So in here we're going to discuss the forces that is being developed by the moving fluids. So and its importance in the analysis and design of such as pumps, okay, turbines, airplanes, rockets, and mini hydraulic devices. Now, going back to the principles of Newton's law of motion, so it is stated that a body at rest will remain at rest, or in motion will remain in motion with a uniform velocity along a straight line. So until acted upon by an external force, so that will be called the law of inertia. So the explanation of this one, for example, no, if we have call this a fine surface, so let's draw a fine surface here. If I have a ball, so traveling at this distance, at this side now, so it will continuously to move at a certain the given velocity, okay. Now if there is for a uniform will continuously move, so until the time that is acted by an external force, so that is the time that it will stop. So continue traveling and rotating until an external force is acting on it, or by means of friction, okay. So that is one way para kung wala man siyang babanggaan na ano, so it will stop by means of friction, or air that is acting towards doon sa sphere natin that is rotating at this direction papunta doon. So that explains the law of inertia. Then next we go to 2. Next we have a particle acted upon by an unbalanced force system has an acceleration in line with and directly proportional to the resultant of the force system, and inversely proportional to its mass. So this explains yung equation natin from physics, going back that one. So that will be yung force is equal to the mass times your acceleration. Now thirdly, we have for in every action there is always an equal and opposite reactions. So the law of stress, or it can be pwede ring tawagin sa human nature, that will be also the law of karma, no? So for every reaction you exert in an activity, so it corresponds to a given responsibility. So pwede siyang tawagin ng law of karma. Now, so this also explains pala na from tawag natin dito, going back to your strength of matter or deformable body. So for example, if you apply the force sa object, if this is a cylinder, now there will be a corresponding reaction of the force, which yung reaction force is the reaction of the material strength. So if the force is greater to the reaction force, so the tendency or reaction force, or let's say the reaction of the reactional force of the material, so the tendency of your cylinder deforms. So nagkakaroon kayo ng deformation doon sa cylinder. So if pag mataas yung force compared to the strength of the material. So that is the law of stress. So let's go to the force against the fixed flat plates. Now we have here consider a jet now shown in the figure. So we have here a jet. So usually this comes from a nozzle. So if I have a nozzle draw here, so example here, if I will going to draw a nozzle, okay, so drawing a nozzle towards here, so that one, okay. So we have this spray of jet of water on the fixed flatbed, so fixed plate, so which is held normal to the path of the jet. Now before contact, so we have the mass one, so we have this one, which moves initially with the given velocity v1, and as it strikes to the plate, so its velocity in the x direction, so we have here your x direction here. So we have here your nozzle, so I'm gonna draw here, so right here our nozzle, so this one, so ito yung nozzle natin. Now our nozzle eject or fires the fluid at the given velocity, no? So as mag-impact siya doon sa flatbed or fixed flatbed, so it changes velocity from v sub 1 to v sub 2. So v sub 2, which is less than the v sub 1. So this change in velocity is caused by the force exerted by the plate on the jet. So as I already described ng third law, for every reaction there will be an equal and opposite reaction. So that's why it changes the velocity from v sub 1 to v sub 2. Now by the Newton's second law of motion, so we have your force is equal to the mass times your acceleration. Now we can express our force in terms of your acceleration, which is that will be the velocity 2 minus the velocity 1, no? And it is divided by the time. Okay. So since our mass, so we can also express that our mass in terms of density, which is equal to the mass over the volume. And in terms of mass, okay, so we can rewrite our equation to mass times your mass times your volume. Or let's say, so para hindi tayo magpareho ng ano dito, so I will try to rewrite this one para hindi tayo pareho ng symbols ng unit natin ng representation. So I'm gonna change this one to the little v sub 2, and change this one also, so little v, okay, like that symbol. So this is velocity and this is now your volume. Okay, so substitute natin to sa equation. So we have your force now is equal to, in terms of mass, that will be density times your volume. So usually this become, if we're going to use mass flow rate, this will become also a volume flow rate. So this is now your volume flow rate and this is your mass flow rate. So using this one, substituting in our equation, so we have velocity 2 minus your velocity 1, then divided by your time. Okay. And also, we all know from your continuity equation that our volume flow rate, okay, is equal to volume, or let's say the volume. So when we say merong dot dito, that is a flow rate. Now volume divided by your time, so that is also equal to the volume flow rate. Then we can express our, so this will become, okay, so we're using here volume flow rate. So yung una, so let's change this one first initially, so we don't have the mass flow rate here. So considering yung equation, so going back, so let's try to remove this one. Okay, so going back, so we have now your volume flow rate. So this is now expressed, your force now is equal to the density times the volume flow rate, okay, which is multiplied to the velocity 2 minus your velocity 1. Then we can further express in terms of specific weight. We all know that our specific weight is equal to weight divided by your volume, or let's say that will be mass, no? Times the gravity over the volume, which is this one is equal to your density times your gravity. And we can express our density is equal now to the specific volume divided by your gravity. So substituting that one to our equation, so we have density, specific weight times the volume flow rate divided by your gravity. Then this is will be multiplied to the change in velocity from 0.2 to 0.1. Now this force is the one that is being inserted by the plate to the fluid. So ito yung dalawa na yan. So we have this one. Okay. Now from the Newton's law, or the third law of motion, the force exerted by the plate is equal. Okay. So from the summation, okay, so let's try to do summation of forces along X. So we have here the force of the fluid. So I'm going to name that as FF, that is the force of the fluid. Okay. Then the force exerted by the plate, which is FP, force of the plate. So if you do a summation of forces along X, okay, so we have the force. So this is now, if we're going to equate it as a 0 initially, so if there is no movement, so if the force FF is equal to the negative or opposite reaction of FP, of the force of the fluid. So by that one, we can say that our force, no, the force on the fluid is equal now to negative force of the plate. Then we can say that our force on the plate, the reaction of the force of the fluid, is equal to the specific weight. So this will be negative times the volume flow rate divided by the gravity times the change in velocity from 2 to change in velocity 1. Now, since may negative tayo, if we're going to distribute that one, pasok natin doon sa loob, so we have the specific weight times the volume flow rate divided by your gravity, then multiplied by the velocity 1 minus your velocity 2. Now, if the plate is fixed, so let's try to if the plate, no, if the plate is fixed, so ibig sabihin stationary, so the velocity at 2 is equal to 0. So there is no movement of the plate. Okay, so then the above equations becomes your force in the plate is equal now to the density. No, it's going to be density times the volume, change this one to volume flow rate times the velocity, or this will be force on the plate, or the reaction. So okay, so this can be represented as the specific weight times your volume flow rate divided by your gravity, then multiply by the velocity. So we have now the force. So and solve that. That is for the fixed plate. Now for the force against the fixed curve beams. So we have here your beams. Then we have here your nozzle injecting a jet of water flowing from point 1 to point 2. So we shall have your x and y components for the total force exerted by the fluid, so against the fixed curve or fixed curve plane. So we can express that one. So if you can still remember from your statics, so we have your x and y components. So we're going to apply the x and y component reaction. So we're gonna apply that one here. So we shall have your x axis and we have your y axis. Then we shall have your resultant. So hindi na natin ipa-plot according so we will assume the angle na lang dito kung ilan yon. Assumingly we have that angle. So for just a representation, so we have the force at the x-axis and we have at that direction, and also we have a force at the y direction going in. Then we shall have your resultant force acting toward here at an angle of your theta. Now for the x-axis, so we have the force is equal to the density, then this is the volume flow rate, okay, times the velocity 1x minus your velocity 2x. So this is the force acting on the plate, the force of reaction of the plate. So this is also equal now to the volume flow rate times the specific weight divided by the gravity multiplied by the velocity 1 x-axis minus your velocity at 2 at the x-axis. Now for our for the force at the y-axis resultant or the reaction of the plate, so we have again your density times the volume flow rate times the velocity at 1 at the y-axis minus the velocity 2 at the y-axis. Okay, then it is equal to the volume flow rate. Then we have a specific weight divided by the gravity multiplied by the velocity 1 at the y. We have the velocity 2 for your y. Then we shall have our resultant force now is equal to the square root. Okay, so familiar naman lahat dito. So this is from common review lang din natin from your mechanics or statics. So statics na pala yan ang pangalan niyan. So we have your for the x-axis the force that will be squared plus your y raised to squared. Okay. Now for that angle of this one, so we have your tangent of theta, which is equal to the force at the y divided by, so that will be opposite, your opposite, and what will be your adjacent? We have your x here. So we can solve out what will be the reaction for the force against the fixed curves or fixed curve beams. So ito lang yung mga equation that we needed, so you can solve that one. And so take note, class, so since force and velocity are vectors, so vector quantity, so yung direction niya so must be considered. So kung ang forces or velocities are on the right, so and upward, so they can be considered as a positive sign, while if yung opposite, if the force or the velocity are on the left or which have downward, shall have a negative sign. So take note of that one. So one consideration now we have to tackle, if the friction in the vane is neglected, so it means that the velocity at point 1 is equal to velocity at point 2. So